And I got interested in zinc for some reasons. And it turns out that zinc is really important in sensory perception. I worked on the hippocampus at first, the center of learning and memory. But it's the sensory perception that's really pretty cool. Your eyes. So we worked with collaborators, because I don't know this stuff, but I find collaborators who help me. And that's the other thing is, you know, you want to do science, it's very collaborative. And I don't believe that the best way is to build a building on a campus and bring a lot of people together and say, okay, guys, collaborate. I think you have to have a lot of lone ranger scientists out there with their eyes open, making discoveries, and then saying, I need to find the person who can do this, and then find them anywhere in the world and go there, send somebody there, or bring them to you, or bring somebody from their lab to you, so you can learn that way, rather than, it's more artificial the other way. So, anyway, just give you one little vignette, and we'll stop on this. Probably the most interesting thing was olfaction. We haven't published this yet. But the olfactory bulb, so odors are interesting, right? And very chemical. And so the olfactory bulb is here in the brain, and then you have a certain number of receptors. And we built fluorescent sensors that allowed us to see zinc specifically. So when zinc comes inside the cell, and the reason we did this was, in neurons, you have a presynaptic neuron and a postsynaptic neuron. They meet at something called the synapse. And the presynaptic neuron has in it these little vesicles, these small little bags of chemicals, with a universal transmitter, which is what? Glutamate. So glutamate is usually pushed out of the presynaptic neuron, across the synaptic cleft, binds to receptors on the postsynaptic neuron, so-called glutamatergic receptors like AMPA receptor, and NMDA receptor, and methyl D-aspartate, they're acronyms. And I could easily, acronyms are terrible in this field. But the zinc, there are little bags of zinc, millimolar concentrations that get released, and nobody, for 50 years, nobody knew what they did. And they added chelators like EDTA and so forth, but they didn't catch it. So we invented a fast chelator that worked 1,000 times faster than EDTA, and then we could see everything with a collaboration of a fellow at Duke.